Hi, my name is Chad Cremer. I'm a master's student at the University of Illinois, Urbana-Champaign with the Department of Natural Resources and Environmental Science. Today I'll be discussing my project, which is investigating the spring migration timing and stopover duration of Sora and Virginia Rail in central Illinois, while using the Motus Tracking Network to monitor regional movements. Sora and Virginia Rail belong to the Rallidae family, consisting of rails, coots, and gallinules. While coots and gallinules often use open water, similar to waterfowl, rails are secretive and spend most of their time in dense emergent vegetation. This results in rails being heard more often than seen, which makes estimating population size challenging, especially outside the breeding season when vocalizations are reduced. Both Sora and Virginia Rail are state-listed game species in many U.S. states and Canadian provinces. However, hunting pressure likely has little impact on population status due to a decline in hunting popularity over recent decades. The IUCN lists both Sora and Virginia Rail as species of least concern. However, Ohio, Virginia, and Indiana have special conservation statuses assigned due to the lack of available data. When considering migration, which is the most energetically demanding portion of the annual cycle, it's critical there are quality stopover sites along their migration routes that provide resources for recovering and refueling to alleviate potential carryover effects that may impact survivorship and breeding success. On the right, there are range maps showing the Sora breeding through much of the US and most of Canada, and overwintering in southern portions of the US, throughout Central America, and extending into parts of South America. The Virginia Rail's range is similar to the Sora, but less extensive, leading to the assumption that Virginia Rail are short distance migrants, while the Sora is a long distance migrant. It is believed both species are low flying nocturnal migrants due to the number of mortalities found under radio towers and power lines. This project is the first in Illinois to evaluate the spring migration of Sora and Virginia Rail, providing baseline information for migration phenology and stopover duration locally, and identifying factors that affect departure behavior, as well as monitor regional movements using the Motus Tracking Network. And hopefully this information will contribute to the management of wetlands for rails. Our two study sites are Imiquon Preserve and Banner Marsh State Fish and Wildlife Area. We have 3 Motus towers at Imiquon Preserve, 1 at Chautauqua, 2 at Banner, and 3 at Dixon Waterfowl Refuge, roughly 70 miles northeast of Imiquon. Both Imiquon Preserve and Dixon Waterfowl Refuge are wetlands of international importance under the Ramsar Convention, representing high-quality habitat. We use walk-in confusion traps assisted with a solar-powered audio lure. There are currently 11 traps at Imiquon Preserve and 3 traps at Banner Marsh. Trap placement is based on habitat characteristics consistent with moist soil environments and vegetation structure. Traps are deployed starting in mid-March for the possibility of capturing early migrants and end in late May to avoid tagging potential nesting rails. The audio lure plays 30 seconds of Sora vocalizations, followed by a 30-second pause, then 30 seconds of Virginia Rail vocalizations, and then a 1 to 2 minute randomized silent period. Captured Sora and Virginia Rail are banned in using USGS ankyloi leg bands. Morphological measurements are collected, and if the bird meets a minimum weight requirement, we can apply a Motus tag. The Motus Tracking Network is a network of automated radio telemetry receiving stations where detections are uploaded to a centralized database for researchers to access. We use low-tech coded VHF nanotags with a 7-second burst interval that has an expected lifespan of 396 days, allowing for the possibility of receiving detections through a full annual cycle. These tags weigh 1.7 grams and is placed on the sensacrum using the modified leg loop harness as seen in the photo. Between the spring of 2021 and 2022, we've banded a total of 332 rails, with slightly more being banded in 2021, possibly due to a cold snap that we experienced in early April of last year. We do capture almost 3 times more Virginia rail than Sora, even though there are plenty of Sora at Imiquon. One possibility for the difference in captures is that Sora breed further north and begin their breeding season later than Virginia rail, so Sora may not be as responsive to the audio lure earlier in the season. Between both years, we've deployed a total of 98 tags, with more tags being deployed in 2022, given how many rails we're able to catch in 2021, and more tags being applied to Virginia rail due to the difference in captures. This year, our goal is to deploy 90 more tags. To estimate migration timing, we're using capture rates of unbanded rails. These 2 graphs show the number of rails caught each day, with the top graph representing Sora and Virginia rail on the bottom. The x-axis is the date, and the y-axis is the number caught. Blue represents 2021, and 2022 is orange. Our earliest capture was a Virginia rail that occurred last year on March 23rd, and our first capture of 2021 was a Virginia rail on March 31st. Captures peak around mid to late April and begin tapering off early May, with our last capture occurring on May 19 in 2021 and May 24th of last year, both of which were Virginia rail. Using departure data from our Motus towers, we're able to estimate the minimum stopover duration from the date a rail was tagged to the day of departure. Between both species, across both years, the minimum stopover duration averaged around 12.5 days. The trend lines for Sora and the top graph are relatively flat, with a minimum stopover duration ranging from 1 to 33 days. There is more variability in the bottom graph when considering Virginia rail, who have a minimum stopover duration ranging from 1 to 51 days, and a greater slope in 2022 compared to 2021. It appears that Virginia rails arrive earlier in migration tend to have a longer stopover duration than those arriving later in migration. Or another possibility was their stopover was longer due to the cold snap in early April of last year, forcing the birds to stay longer than they normally would have. The slope for 2021 may be flatter compared to 2022, since less tags were deployed earlier in the season of 2021, when Motus Tower troubleshooting was still occurring. So it'll be interesting to see how 2023 will compare. Along with departure data received from our Motus towers, we're also able to see what time tagged rails were departing the study area. Between both species, across both years, tagged rails were leaving on average 90 minutes after civil twilight. It is interesting, when there are multiple tags departing on the same night, just how close the departures are to one another. For example, on May 12th last year, 5 Virginia Rail all departed within a 60-minute window of each other. No departures were observed before sunset, and the latest departure was a Virginia Rail last year in early April, roughly 5.5 hours after civil twilight, with very few other departures occurring after 3 hours of civil twilight. When considering factors that may affect departure behavior, so far the two that stand out the most are wind speed and direction and cloud cover. This graph is a wind rose showing what direction the wind was blowing and with what speed in miles per hour at ground level on nights Sora and Virginia Rail departed in 2022. There were 25 departures occurred with what would be considered a tailwind, and the wind speed averaged 11.5 miles per hour. Only 6 departures occurred with a headwind, and that wind speed averaged less than 5 miles per hour. The 10 remaining departures were considered a crosswind that averaged 10 miles an hour. When looking at cloud cover for departures, both species in 2022, there were 42 departures on nights with clear skies, 15 on partly cloudy nights, 4 with overcast skies, and 4 departures occurred when rain was in the area. This is a map of active Motus towers with the Sora and Virginia Rail range maps in the lower left-hand corner for reference. There is a higher density of towers in the northeast than in the west, so should any of our tagged rails migrate to the northeast, there should be a higher likelihood of receiving a detection compared to a lesser probability for any rails migrating north or northwest. I would like to also point out the line of Motus towers extending from northwest Illinois through Minnesota to Manitoba and Saskatchewan, as well as how few towers there are in other portions of the prairie pothole region, such as North Dakota and South Dakota. This is a map of regional detections for our Sora, with green lines representing detections reported during spring migration, and orange lines are detections reported during fall migration. It is important to point out that a detection does not imply that is where a bird stopped, but simply passed close enough to a tower to be detected. It is not known how much further a bird may have traveled beyond the last reported detection. It is also important to note that the lines are simply connecting tower detections and only assume the flight path, and as time increases between detections, the larger the assumption. For example, if 2 detections are only a few hours apart for towers separated by 100 miles, then straight line travel is highly likely. However, if in that same scenario, the detections are separated by a week, then there is more uncertainty of where that bird could have gone during that time. Given the higher density of Motus towers in the northeast, we've only had 1 bird get reported east of Illinois after traveling up to Madison, then heading east where its last detections occurred over the course of a couple days as it checked in several times in the Toronto area. The remaining Sora have been reported following the line of towers from northwest Illinois through Minnesota, with several being reported in the Winnipeg area. During the fall, detections have occurred in Iowa, Missouri, and Kansas. Here in this slide, we see the detections for the Virginia Rail with more variability, but still migrating north-northwest for the most part, with a couple checking in near Winnipeg, similar to the Sora. To date, the longest migrant we have in our project is a Virginia Rail that was reported in Saskatoon in the spring, and it took 11 days to get there from central Illinois. And even though we don't have a departure date in the fall, when it went through Kansas and got detected there, it was later detected in Galveston, and the time it took for it to get from Kansas to Galveston was 21 days. To recap what we're observing so far, although these numbers are likely to change with another season of data and further analysis, but it appears the migration timing begins in early April and peaks mid to late April, with the estimated minimum stopover duration of 12.5 days. The time of departure is roughly 90 minutes after civil twilight, with wind direction and cloud cover being factors influencing departure behavior. It also appears that Sora and Virginia Rail that migrate through Illinois in the spring are breeding in the Prairie Pothole region and migrating back through the Mississippi Flyway during the fall. I would like to thank the funding sources that makes this research possible, and my advisors Auriel Fournier and Mike Ward, as well as the staff at the Forbes Biological Station and the numerous grad students and field technicians that have helped me along the way. And with that, I would be happy to answer any questions. Thank you.